Well, I got a stepper motor hooked up to the C3 demo board this time with the UNL 2000 breakout board here, and I got a cheap power supply here, a bench top power supply here set at 5 volts, and you can see the program will spin it counterclockwise and then clockwise. And basic setup. I'm running the input. I got the input from the demo board into the UNL driver board. I'm tapping off jumper 3 on the demo board. Just ran some wires, hooked the 4 inputs on the breakout board, and then here's there's a couple of inputs for the power supply, which I just have a couple wires coming out of those, and then hook the alligator clips to the bent supply to these, one positive, one negative. And you can see it flashing. It's a little heartbeat routine I put in my programs, just to make sure communications of the board, things are halfway working and other stuff doesn't work. Here's the wire up diagram I got for the breakout board. Like I've already said, I got the positive for the power supply going to the positive on the power supply, and then the ground for the benchtop power supply hooked up, and then the 4 inputs for the stepper motor starting at port A4 and running down to port A7. You can see here in jumper 3, I just grabbed these ports because they're available. There's nothing wired into them on the board, and it's just port A4 through 7. And then the program itself, I got some defines listed up here. My LEDs for that heartbeat function. It's the built-in LED in the demo board. It's on port R, pin 0. And then I've got the input defines, as I stated, from port A4 up to 7. And initialized, created a variable for the switch function. And then 2 functions counterclockwise direction. Spin the stepper motor counterclockwise, and then 1 for clockwise. The main program has the board initialization for the C3. Always have that, and then initializing I/O ports, and then setting the pin directions for the I/O ports. These are all going to be outputs. These are outputting from the demo board to the stepper motor driver, as for the LED as well. And just have the heartbeat function in here, or I'm toggling the pin with a half a second delay, and that'll just be continuous. And then the actual 2 stepper motor functions just run every time I hit the program button, flash the program. It'll run one time, and the functions are down here. The counterclockwise functions, I have it inside. I have a for loop. Let's see, up here I have it set for 800 times, so it'll go through whatever I set in the parameter here. It's the number of times that the for loop will iterate through, and basically iterating through a switch statement, and having the pin levels set, the inputs 1 through 4, having the pin level set in the right sequence to move it through each part of the rotation. So three falses or three lows. I've got my highs and lows mixed up, but they're all just booleans. False same as low, high same as true, and so the so the stepper counterclockwise function set to 800. So the function call is 800 in the parameter. So integer I is equal to 0. And is I less than 800? Yes, it is. So then it goes to the nested for loop. And this has 7 iterations through it. So x is equal to 0, x is less than 7. So the first switch input is x is 0, or the case is 0. So then it sets the port pin levels 1 through 4, 3 false and 1 high. Then breaks, goes back to x is now 1, x is less than 7. So the switch is now case is now stating 1, and gives false false, true true to the 4 inputs, etc. Doing that all the way down for 7 cases, 8 altogether. You notice that there's a 1 millisecond delay between each one, and you can change that delay to speed up or slow down the rotation. And the clockwise function is exactly the same with the two, the for loop from the parameter and the nested for loop, except that all the sequences are just flipped. So the sequence, the case for pin 7, or I mean for case 7 in the counterclockwise is going to be the case for case 0 in the clockwise. In other words, case 0 for the clockwise is high, low, low, high. Nope, not too far. And then you can see it up here. So case 7 for the counterclockwise is high, low, low, high. And then the default for both of them is all low, setting all the inputs to low. So that's it's pretty basic. It gets some simple functionality going.